Hello out there. Thanks for joining us today. This is our Water Year 2023 Early Season Water Supply Outlook webinar. I'm Cody Mosier, a hydrologist at the Colorado Basin River Forecast Center. Here is what we'll be covering today, starting with observed precipitation over the past several months, and then taking a look at our hydrologic model soil moisture conditions entering the winter, also known as fall antecedent soil moisture conditions, and then taking a look at current snow conditions, and then into our ESP ensemble streamflow prediction forecast method overview, and then looking at early season ESP model guidance for the 2023 water supply season, moving into upcoming weather and the status of the El Nino Southern Oscillation, and then ending with the webinar schedule and forecast points of contact for this upcoming season. Please mute your phones during the webinar. If you have a question, you can enter it into the chat box, and we'll also open it up at the end for a Q&A session. And this webinar is being recorded, and so the slides and the recording will be available on our webpage later today. Jumping right into precipitation during the last 6 months of water year 2022. So starting along the top left here, April and May. This ended up being a record dry April and May over Arizona here. As you can see, the pink colors, here's the legend. So Arizona, less than 30% of average precipitation during April and May. Into June, the monsoon season got started in June, brought some nice precipitation down Arizona and southwest Colorado, and that precipitation continued into July, August, and September, with many areas receiving precipitation during those months. And then the image on the right here, just a recap of water year 2022. So this would be October 2021 through September 2022. And this is percent average precipitation. You can see lots of oranges and yellows. That's kind of near, slightly below average. Some areas did come in a little bit better. Northeast Arizona, for example, in the Little Colorado River Basin area, and then some parts along northern basins, but generally near to below average for last water year when it comes to precipitation. So in summary, for water year 2022 here, it's very general, below normal snowpack and spring runoff, followed by a favorable monsoon season. The table on the left here, this is showing observed unregulated streamflow volumes. Most basins, it's going to be an April through July volume in thousands of acre feet, also known as CAF. And then, so the volumes in the middle column here, and then the percent normal in the right column. I'm not going to go through all these numbers. You can reference them later. A few basins in the lower Colorado River Basin with the asterisks here, that's a January through May period. But the takeaway, below normal runoff last year, pretty much everywhere. And then the map on the right here, this is looking at July through September of 2022, roughly the monsoon season, and this is showing precipitation departures from average. So those bluish green colors means above average precip, which you can see covered much of Arizona. Dating, if you go back to June, in this previous slide here, as you can see, as the monsoon season got off to a start in June. If you're looking at the June through September period across Arizona, it was the 9th wettest. So some good news there across the lower Colorado River Basin. Now into water year 2023 precipitation. So October and November, first 2 months of the water year. starting on the left here in October. So moisture continued over southern and eastern basins during the first half of October, and snow started to accumulate during the last 10 days of October. On to November here, much drier over Arizona and eastern basins. There were a few storm systems that moved through the region during November, with Utah receiving more precipitation than both Colorado and Arizona. And just some numbers on the right here to summarize October, November. So the first 2 months of water year 2023, precipitation as a percent of average. This top section here, the upper Colorado River Basin, October, November precip below average. In the middle section is the lower Colorado River Basin, near to above average there for October, November, and the Great Basin came in right around average. First 2 months of water year 23. Now into December, so this is looking at precipitation to date. And for December, the first two graphics here, as a percent of average, again, precipitation has moved through the region during the first half of December, with most areas receiving some kind of precipitation. This graphic in the middle here is precipitation totals at snow tells. A lot of numbers here, but just focusing in on the blue dots, anything 3 inches or above. You can see, many areas got 3+ inches of precip so far in December along the Wasatch, Northwest Colorado, moving down even into Southwest Colorado, Central Arizona, and Southeast Arizona, all receiving at least 3 inches of precip at some of these snowtail stations. And then water year to date, so this is the first two and a half months of water year 2023. Southeast Arizona really stands out for being above average so far this water year. Upper green here in Southwest Wyoming. And then this area here, kind of the lower Colorado River main stem below average, as well as along the Continental Divide. Some of these lower elevation areas in western Colorado have benefited from precipitation this water year. It has helped out with some critical reaches when it comes to endangered fish habitat there. So was nice to see. Now into our model soil moisture conditions for fall of 2022. So the map here showing our model soil moisture conditions from the lower soil zone in our hydrologic model. So the modeled lower zone soil water content is a result of past hydrologic conditions, including runoff from previous years, summer, fall precipitation. We adjust this if needed in our model during the fall, hopefully during a dry period after irrigation season has ended and before winter has set in and frozen up some of the stream gauges out there. And we use everything from early November stream flow observations, also known as base flow conditions, reservoir inflows, at monsoonal into early fall precipitation, and then runoff conditions from past seasons. So the takeaway here, heading into water year 23 winter and spring runoff. So our soil moisture conditions are near to below normal across many of the major runoff producing areas. So looking at starting with, say, western Colorado here, oranges and yellows, that's going to be kind of the 70 to 100%. So many areas falling there. A little bit, so this is the southern Gunnison, a little bit worse off there. Along the Great Basin, soil moisture conditions in the Great Basin within our model are worse off, much below average than the upper Colorado River Basin. And then looking down across the lower Colorado River Basin in Arizona, southeast Arizona, kind of along the New Mexico Arizona border there, upper Gila, Salt River Basin area, soil moisture conditions sitting above average, largely as a result of the monsoon season precipitation, and then not quite as good when it comes to soil moisture conditions in central Arizona. So generally better conditions in the Colorado River Basin compared to the Great Basin. And here we're looking at a comparison of our fall model soil moisture conditions. So on the left here, this is back November 2021, and then November 2022. So this year in the middle there, and then the graphic on the right there is a difference map. With the differences, so where soil moisture conditions are worse off than they were, those are going to be in the oranges, and where they're better off is going to be in the green colors. So as you can see, compared to last year, soil moisture conditions in the Great Basin are worse off. That's also true for the upper green. And then as you move into Northwest Colorado, pretty similar soil moisture conditions within our model. And then as you move south into Southwest Colorado, the San Juan River Basin, soil moisture conditions a little bit better off this year compared to last year. And then across the lower Colorado River Basin, better off in the eastern part and worse off with some similarities in central Arizona. Now taking a look at mid-December snow conditions. So here we're looking at the squares on this map are NRCS SNOTEL stations, and the areas that are colored in, that's our hydrologic model snow conditions. And this map is showing percent median snow water equivalent. So mid-December snow conditions are best off in the Great Basin, sitting above normal. The numbers down here in the table, across the upper Colorado River Basin here, they're sitting above normal in the White Yampa here, Northwest Colorado, kind of near normal in the Colorado River headwaters area. And then if you look in north and south of those, the upper green, kind of depends on where you are in the upper green. If you're up here, not quite as good as say the north slope of the Uintas down here. So a bit of a mixed bag in the upper green. And then Southwest Colorado, right around normal, which is not quite as good as everywhere else in the upper Colorado River Basin, but we'll take near normal. In the lower Colorado River Basin, you can see only a handful of SNOTEL stations down there. These percentages much more variable, which is not uncommon, you know, given the types of events. Is it rain? Is it snow down there? So it's pretty common to see some pretty highly variable percentages in the lower Colorado River Basin. But the takeaway, best conditions across the Great Basin when it comes to snow, and the upper Colorado River Basin sitting near to above normal for mid-December snow conditions. Here we're looking at mid-December snow conditions, 2021 versus 2022. So at this point last year, we were much below normal when it comes to snow conditions. Snow really picked up in terms of accumulation during the last half of December. But if you're looking at mid-December, much better this year compared to last year. Okay, when it comes to looking at early season water supply model guidance, at this point in time, ideally, our model soil moisture and snow states are accurate and representative of the current conditions out there. Soil moisture is still heavily influencing the ESP model guidance. Our early season forecast errors generally range between 20 to 40%. And typically improve through the spring as the snow season, as we find out more about how the snow season is going to play out. The primary source of forecast uncertainty is future weather. And sitting in mid-December, when it comes to snowpack conditions, typically around a third of the seasonal snow has occurred by this point. Normal snowpack value still small compared to later in the season, with ESP being more sensitive to SWE now than later in the season. And just an example here, so a two-inch SWE surplus or deficit is more impactful now compared to, say, in April. Here we're providing an overview of our ESP forecast methods. So ESP stands for Ensemble Streamflow Prediction. So basically, how we run this is we take our current hydrologic model states, so that would be the current soil moisture and snow states within our hydrologic model, and we feed through future weather, so precipitation and temperature scenarios based on what's happened from 1991 through 2022. So we feed through weather observations, and the result is in April through July streamflow volume. An example here, Dillon Reservoir, the inflow into Dillon Reservoir. This is from our ESP model run yesterday. So 2022, our current model states, and we feed 1991 weather through, and we get 143,000 acre feet, also known as CAF, if we were to see the weather that occurred in 1991. And then we do the same thing, current model states for 1992 weather. We get April through July volume, so on and so forth, all the way through our current model states with 2021 weather pattern. That would result in 141,000 acre feet. So the final result here, 30 different possibilities or traces of April through July streamflow volumes. And we use statistical analysis to determine some probabilistic outcomes. For example, the volume that has a 50% chance of being exceeded, volume that has a 10% chance of being exceeded, volume that has a 90% chance of being exceeded. These are some examples here. And we can calculate a percent of average by taking that 50% exceedance volume, dividing it by the average observed volume during that 30-year period, 1991 through 2020, and then getting a percentage there. So in this particular example from yesterday's ESP run at Dillon Reservoir, the volume that had a 50% chance of being exceeded, 157,000 acre feet, with the 30-year average being 167,000 acre feet. That would give us a 94% of average ESP guidance. And we do run our model every day and publish our results to our webpage for all of our forecast points. So jumping right into our ESP model guidance, this is from yesterday's model run across the Upper Colorado River Basin. So here we're looking at April through July runoff volumes as a percent of the 1991 through 2020 average. You can see the white Yampa doing a little bit better in terms of conditions, 105 to 115% there. A little bit better snow conditions going into that, as well as the Upper Colorado River headwaters. And then again, as you move north and south of those areas, a little bit worse off in the Upper Green, Southwest Wyoming area, as well as Southwest Colorado. The Lake Powell ESP model guidance from yesterday's run, right around 85% of average. And that Lake Powell, a good summary of the hydro conditions throughout the entire Upper Colorado River Basin. Now looking at our model guidance for the severe, virgin, and lower Colorado River Basin. So on the left here, these are the severe and virgin river basins, April through July runoff volumes as a percent of 1991 through 2020 average down in southwest Utah. So the severe sitting 75 to 110% of average, in the virgin river basin 65 to 90%. And the lower Colorado River Basin, as I mentioned, this is a January through May forecast period. And we're looking at and comparing volumes to the 1991 through 2020% of median here. So again, similar to the highly variable snow conditions down there, some pretty highly variable runoff condition, spring runoff outlook conditions here, anywhere from say 55 down in the Salt up to 220 in the Little Colorado. So highly variable in the lower Colorado, but not uncommon. And then finishing up with the Great Basin here, a little bit better conditions as a result of better snow conditions. As you can see, starting in the Bear, northern Utah, Idaho, Wyoming area, 80 to 110% of the 1991 through 2020 average. Weber and Six Creeks drainages also near to above normal. And the Provo, Utah lake drainage, little below to a little above average, depending on where you're at. Now right into the 7-day precipitation forecast. So this is the precip forecast today through next Tuesday. We're looking at some precipitation over central Utah, Wasatch, high elevation range area, as well as northwest Colorado, although accumulations generally looking less than 1/4 of an inch. And then beyond today, tomorrow, looks like we're going to dry out a little bit with minimal precip chances. And then maybe a little bit more precip entering northern Utah next Tuesday, based on this morning's weather models. And then looking out into the 8 to 14 day period, so this would be December 21st through December 27th. These graphics and forecasts here are from NOAA's Climate Prediction Center, also known as CPC. So just real quick, how to interpret these graphics. So these graphics show the probability or the percent chance of seeing above normal or below normal temperature in the case on the left, and precipitation on the right. So starting with temperature on the left here, it looks like increased probability of below normal temperatures across northern and eastern basins, with a near normal forecast in southern and western basins. And when it comes to the precipitation outlook, again, December 21st through 27th period, increased chances of above normal precipitation across northern basins, with increased chances of below normal precipitation across southern basins. And then out even a little bit further, so this is weeks 3 to 4, so this would be the December 24th through January 6th period. When it comes to temperatures, slightly increased chances of below normal temperatures over most of our forecast area here, and small area here with increased chances of above normal precipitation. That would be northern Utah, southwest Wyoming, with the remainder of the area seeing equal chances of above or below normal precipitation. So the weeks 3 to 4 outlooks here, these are a little dated, issued December 9th. They'll be updating these Friday, if you're interested in checking back on those. Now into the El Nino Southern Oscillation, or ENSO, the status of that. So La Nina is expected to continue into the winter. And what does La Nina mean? It means increased chances of drier winter weather in Arizona and lower Colorado river basin. So you can see down here this graphic, La Nina winters. Generally a pretty strong correlation with La Nina events and drier winter weather across Arizona and the lower Colorado River Basin. There's a much weaker correlation or winter weather signal elsewhere in the basin. So that would be Great Basin, Upper Colorado River Basin, not a strong signal there when it comes to the ENSO status. And the last two bullet points here, just kind of summarizing these graphics on the right here. So in the upper right, this is the official probabilistic ENSO forecast from early December. So you can see come January, February, March period here, there are equal chances of being in a La Nina phase or ENSO neutral. So equal chances for seeing those. And then as we move forward out into February through April, about a 70% chance of ENSO neutral status come February, March, April. And the graphic on the lower right here, just all of the models that go into predicting the ENSO, El Nino Southern Oscillation. And one more thing on El Nino here. So it's likely that this is going to be our third La Nina winter in a row. This would only be the third time since 1950 that this has occurred. And I grabbed these graphics and quotes from NOAA climate.gov. There's a link down here if you want to read into it more. But the takeaway, there's nothing obviously different about La Nina three-peats relative to all other La Ninas that would lead to markedly different expectations. So if you look at these graphics here shown on the right, these are all of the cases where there were 3 La Ninas in a row. So this first one, 73, 74, ending in 75, 76. And you can see, you know, with browns being drier than average, pretty common in all of these, question mark here. So again, we'll see what happens, and you can see how ENSO phases have changed over time here, dating back to January of 1982 through current time. So then looking at the seasonal outlook from CPC, so this is the December, January, February 3-month outlook with temperature on the left and precipitation on the right. You know, typical of a La Nina pattern with increased chances of warmer and drier winter weather across Arizona, lower Colorado River Basin. Not surprising given where we're at with the La Nina. Okay, so to summarize, just by region here, starting in the upper Colorado River Basin, soil moisture, again, generally below average across the upper Colorado River Basin. And compared to last year, a little bit worse off in the upper Green River Basin, similar across northwest Colorado, a little bit better down in southwest Colorado. Snowpack in the upper Colorado River Basin sitting near to slightly above normal. Best conditions, again, white Yampa. Currently, water supply guidance anywhere from 75 to 115%. of the 30-year average, with Lake Powell ESP model guidance currently around 85% of average. Down in the lower Colorado River Basin, soil moisture generally below average down there as well, with the upper Gila, upper Salt being the exceptions, and those basins having above average soil moisture conditions. Again, the snowpack highly variable down there, anywhere from 45 to 210% of normal, given the handful, 5 or 10 SNOTEL stations that are down there. Water supply guidance, again, following suit, 55 to 220, highly variable, and that's a January through May period. 1991 through 2020 median is the central tendency there. And then the Great Basin, when it comes to soil moisture, much below average, worse than last year when it comes to soil moisture conditions in the Great Basin. The Great Basin does have the best snowpack conditions currently, sitting above normal, 155 to 175% of normal, with the current water supply guidance sitting 80 to 140% of average. So weather forecast for the next 2 weeks, fairly confident temperatures will be below normal across northern Utah, southwest Wyoming, western Colorado. The best chances for precipitation, it's not a lot of precipitation, generally less than 1/4 of an inch, but the best chances for that's going to be across those same areas, northern Utah, southwest Wyoming, and northwest Colorado here. Drier weather is likely across southern Utah, southwest Colorado, and Arizona. So the southern basins likely going to see drier weather the next couple weeks. And then due to La Nina conditions, that's leads to increased chances of drier winter weather across the lower Colorado River Basin. So we're, again, most likely going to need above average snowpack to see near average water supply volumes, given below normal soil moisture conditions, generally heading into the spring runoff season. And spring weather, again, always a factor. That's the highest when it comes to forecast air. That's playing the biggest role, is spring weather, and uncertainty in that. Now, taking a look at our operational timeline, sitting in mid-December here, our ESP model guidance will be available on our website in the next few days. We begin issuing our official water supply forecast starting in early January. Those come with water supply discussions and reports issued twice monthly, also starting in early January. And then come early March is when we start issuing our peak flow forecast products. Currently, the soil moisture states in the model have a larger influence on hydrologic guidance compared to later in the snow season. And then as we progress into the winter, snowpack conditions will start to have a larger impact on the forecasts in the upper Colorado and Great Basins. And when it comes to winter rain events, those have the largest impacts across the lower Colorado River Basin. Here is a summary of our upcoming water supply webinars for this season. So all of these times are Mountain Time, and we do break these into 2 separate webinars starting in January, one for the Colorado River Basin, so that covers both the upper and the lower Colorado River Basin. And then at 11:30 on the same day is when we put on the Utah Great Basin Water Supply Forecast webinars. We do break these out. It gives us a chance to do a little bit deeper dive into more basin specific conditions. And then come mid-March, this year it's falling on March 20th, we put on a peak flow forecast webinar. All this information is on our webpage, which is shown here. So cbrfc.noaa.gov. Under our news menu here, you can drop that down. Clicking on this webinar link, this will take you to our webinar schedules. You can register for these webinars. At the bottom of this page is a link to our presentations page. That'll get you to where these slides and webinar recording will be posted later today. And we have email lists if you're interested in getting involved, being on one of these. Reach out to us. We're happy to add you to these. They include everything from just getting notifications when we issue our water supply forecasts or water supply discussions, that type of information. And I'm going to end here. These are our forecasters, our basin focal points for this upcoming water supply season. Not going to go through all of these, but again, feel free to reach out to us if you have any basin-specific questions for us. This is how you can get in touch with us. Give us a call, shoot us an email. And that's all I had for you today. I'm gonna stop there and open it up for any questions. Okay. So just looking at the question box here, I'll pop this out. So question from Luke Runyon here. Do we factor in La Nina and El Nino into these water supply forecasts at all? The answer is yes. And that's only for the lower Colorado River Basin. Again, there is a pretty well-established signal when it comes to the ENSO status, whether it's La Nina or El Nino. So there's a pretty strong correlation there when it comes to winter weather across the lower Colorado River Basin. So we do weight our ESP volume traces depending on the ENSO phase down there. So that does have an impact on our water supply forecast only across the lower Colorado River Basin. Another question here, can we talk a bit more about what goes into the 85% of average runoff into Lake Powell? Is that just snowpack or a combination of snowpack and soil moisture? So that 85% of average runoff into Lake Powell, that's taken into account both model soil moisture, model snowpack, yes, both of those things. And then that would assume climatology, basically. It would assume normal temperature and precipitation from today through July 31st, through the forecast period. So that is what's driving that 85% number. You can also raise your hand if you'd like to be unmuted. Not seeing any more now, but I'll keep it open. Hey, Luke, see you have your hand raised. Those couple questions I just answered were from you. Did you have any more we could try to answer for you?
Yeah, I'll just keep going since we don't have any others. I wondered if you guys model at all, like how much additional snow it would take to get to like a normal runoff into Lake Powell given the dry conditions. Do you guys look at that at all?
No, but it's not to say that we couldn't. We have the capability to do that, but it would require, some work, and where do we want to throw the snow in, and it wouldn't be as black and white as you know just throwing in snow everywhere, or it kind of depend on where it is, I think, too.
Mhm.
But yeah, I think it's possible,
Mm.
but something we haven't spent a lot of time on.
Mm. I got one more, if you'll take it.
Sure.
Um, I feel like there's going to be a lot of attention paid to the forecast this year, just with how kind of dire the situation is in the Colorado River Basin writ large. Um, so for maybe people who are like new to this, how should we be framing our thoughts heading into this snowpack accumulation season? Like, is this a good start? Is this like a bad start? Is it way too early to even start characterizing it?
I would first answer is it's way too early to start characterizing it. If you remember, sitting January 1st of this year, we had a huge December snowpack. Snow was well below normal everywhere on January 1st. And I'm going to go back up here to one of my first slides here. So yeah, we were this last season, we were sitting well above normal snowpack pretty much everywhere, and we ended up with, you can see these numbers in the right hand column here. Lake Powell, a little below 60%, basically well below normal everywhere is how it ended up. So yeah, we're happy to see some of the recent snow, but it's, I think, still way too early to get too excited. All right, I'm seeing a few more questions in the chat box here. Looks like there's a tool from NOAA that gets the amount of precip needed to move. I think it's a drought index there. So a tool out there that shows how that can impact or improve drought categories, I think that is, but it's kind of along the same lines of what you were referring to with your question. And I'm not sure if everybody can see this link or not, but I did attempt to put it in the chat and send all of it to you, send it to you all. And that link is from Joe Casola, so thanks, Joe. Jeremy, looks like, hi Jeremy, did you have a question?
No, I was just letting you know that we could see that link that you put into the question box, and shout out to Joe for sending it.
Oh, great, thanks. Okay, with that, I'm going to wrap it up here. Again, you can reference these slides and recording. They'll be on our webpage later today. And thanks for attending. Hope to see you in early January.